So what I have in mind for the session here, I'm going to make myself presenter on my other computer. I find that my Mac is just more friendly to work with for MongoDB. Although it should work in theory just fine on either. Okay. So what I had in mind for tonight, first I'll open it up to general questions, and after that what we'll do is we're going to work through a lab that I've posted in GoToMeeting, or excuse me, in Blackboard. So I'll show you that in case you don't know where it is, and you can download these things and use them yourself. And then I'll post this video, I don't know, a few minutes after we're done. Okay. So if you go into our Week 10 folder, if you go to the, Week 9 folder, must be. At the bottom you'll see hands-on lab materials. There's a sample data file that you'll need, and so that's the data that we're going to use for this lab, and you can download that to wherever you'd like on your machine. And then there's also a PDF file, and I'll click on that. This has what we're going to do. So you'll see here it's got 2 preliminary steps just to load the data, so we'll make sure everybody's comfortable with that. And then there are 8 questions that we're going to answer after that using this data, so you get a sense of how aggregation works. And just so you know, tomorrow night during the meetup we're going to cover MapReduce. So you'll have tonight's lab for the aggregation and tomorrow night's meetup for MapReduce. All right, any questions before we start? Okay, so Tulasi has no questions. Anyone else? Okay. Chipper, are you able to get sound now? Okay, great. And I am recording it. So I'll post this when we're done. Okay, so the lab, the first thing we'll do is we'll load the sample data, and I'm going to use Mongo import. So that should be familiar to you from last time. So the first thing I need to do, of course, is start up MongoDB. So I'll start it in this window here, and then I'll open a new shell window to do the actual work. Okay, and again, MongoDB, when we use Mongo import, that is a utility that is available to us from our regular shell, not from within MongoDB. And so what I'm going to do is I'm going to call this WED Mongo Lab for Wednesday because I already have a Mongo Lab in there for Monday. But this will create the database, and then I'm going to import a CSV file. So type CSV. It has headers, so I'll do the header line call. And then my file, in this machine, it's located at users, Michael Schulte, documents, sampledata.csv. And I'm going to show one more thing on here that's optional that I'm actually going to use tonight. The question's been asked a few times. If you want to put it in a collection that has a different name, how do you do that? This is in the documentation, but it's easy to overlook. You can use this call for collections and then give it the collection name. So lab data. And when I run that, it's not a plural, collection lab data. There we go. Okay, so it should have imported that, and it looks like it's done it correctly because there are 279 observations. So what I'll do now is I'll go ahead and log into MongoDB at my shell. I'll ignore this warning that's not good in a production environment, but for development purposes is fine. And let's just let's show the database is available. And you can see here I've got a MongoLab database from last time, and then I've also got my my Wednesday MongoLab here available. So that's the one I want to use. And if I show the collections, you can see that we have a collection called lab data. If I hadn't told it the collection name up here, if I had left this off, it would have put it in a collection called sample data, since that's the file name, right? But if you want to give it a different name, that's the easiest way to do it when you import the data. Okay, so that's that. Let's just take a quick look at what's in there. So db.labdata .find, and just take a look at some of these records. And let me stretch this out a little bit so it's a little easier to see what's in these things. Okay, so, and it's only going to show as many as fit on the screen, and then you can always ask for more if you want. But each object has an ID number, which is generated by MongoDB, and then there's a date, a location, a shift letter, and an event. And so what you can think of for the events, it could be web page views, it could be calls, it could be orders placed, it could be products made, it could be anything like that. And so I wanted to keep it kind of generic. But so the kinds of questions we'll be interested in are things like, at this location, how many events were there? Or, you know, how many events does A shift have compared to B shift or C shift? Things like that. And so you can imagine here we've got 3 stores, one at West Edge, one at Stadium, one at Oakland. Those are 3 streets in my neighborhood. And then each store has 3 shifts, and then we record the events for each shift at each store. So that's basically what this data look like. So let's go ahead and unless there are any questions, I'll come back to upsert. Actually, I'm going to cover upsert briefly tomorrow, Tulasi. So if you don't mind waiting, I'm going to put you on hold till tomorrow for that one, or maybe if we have time at the end. But we're not going to use it tonight. So we'll start with the questions one by one. The first thing we want to do is count the total number of documents in the collection. And the reason for this, I hope you all know that there's a db.collection.count function. It's actually an aggregation function. There are some built-in aggregation functions. So it's labdata.count. And this just counts the number of documents in that collection. And so there are 279 documents in that collection. But there are more complicated ways we could do that same aggregation using the standard aggregation pipeline. But they do have some that are so common that they've just built in functions to do them for you. The next question is another one of the built-in functions, and this is one where we say count the number of distinct dates in the collection. So what I'll do is db.labdata.distinct is the keyword here, and then I need to tell it which field I'm interested in, and I'm interested in the date field. Now, if I run this, it's going to give me a list of the distinct dates. So there they are. It comes back as an array. And we can count them if we want to. And this covers all of the dates of March 2014. So we can say, well, there are 31. But I don't want to have to count them by hand. What if there were millions of them, right? So this is all JavaScript driven. And while we don't expect you to know JavaScript, there are some useful things to know. And one of them is if a function is returning an array, I can actually append a .length on the end of this call. And it'll tell me the length of the array that's returned. So if I run this, we're expecting 31, and sure enough, there's the count of how many there are, 31. So it will be worth, if you do go down the road, if you do start working with MongoDB regularly, investing a little bit of time in JavaScript is worthwhile. And I can point you at a couple of resources at the end if you're interested. But this .length feature is a really good way to count the results of any of these aggregations that we do. So if you're really interested in how many there are, that's the way to get it. Okay. Next up is question number 5 here. It's another count question, and we're interested in how many distinct locations are there and how many distinct shifts are there. And so I'm going to use exactly the same code except changing the field that we're interested in here. And so we'll see there are 3 locations, and it's a small enough data set that we can verify that by hand if we want to. That's by design. And then I can do the same thing then for shift. So we've got 3 locations, and we got 3 shifts, and the next question we're interested in though is, do all of the locations have all of the shifts? So for each of the 3 locations, do they have all 3 shifts? That's not clear from what we've done so far, right? We've only asked how many of each are there. And so now we're going to get into a little bit more fancy query here. So we're going to start using the aggregate function instead. And I want to tell you we're going to develop a little bit of stuff in sequence here. But the aggregate pipeline, and there's some really good documentation on this in the MongoDB help files. I think they've done a fantastic job of this. But if you go to their help file here, in the aggregation concepts, they have this aggregation pipeline concept. And so it's a 2-step process. And the first step is a match, and the second step is a group. And what that does is it says, match only the documents I'm interested in aggregating across. So for instance, we might say I only want to aggregate at the Westnedge location. So we would write a match statement in order to match up with just Westnedge locations. And then once we do that, it pulls just those documents. So this is the whole collection. It would match only the Westnedge ones, and that's what would be in this second column. Once we've done that, the group statement is what then runs the aggregation that we're interested in. So a lot of times for these aggregations, we're not going to worry about the match statement because we're going to be interested in all of the documents. So there's not always going to be a match statement. There sometimes will be, and there sometimes won't be. Or stage, I guess MongoDB likes to call them stages. So you can see here, I guess it won't let me highlight it. This text here at the top is an example. There's a match stage which says choose all the documents where the status is A. And then there's a group stage, and you can see here they're doing a sum. And so we're going to do examples of these. We'll do a few of these. But that's the idea of an aggregation in MongoDB. And then MapReduce is actually pretty similar, but again, we'll do that tomorrow. Okay, so question number 5. Let me go back to the quiz or the handout briefly. So question number 5 here just says count the number of distinct locations and distinct shifts, and that gave us 3 and 3. Question number 6, though, then says, do all locations have the same number of shifts? So how would we answer that? Well, one way would be to show all of the unique combinations of location and shift. And so that's what we're going to do next. So what I'm going to do, and I'm actually going to assign it to a result, although that's not necessary. But that would let me work with it. So I just figured I'll show you how you can do that. You can assign the output of these calls to a result just by saying result equals, or whatever you want to call it, equals. So db dot lab data aggregate. So we're going to use this aggregate keyword here. And the structure is going to be very simple, like we saw on the documentation. It gets 2 statements, or 2 stages, if you will. And the first statement is the match statement. I'm not going to use that for this one because I want all documents. So we're not going to do a match statement. We'll go straight to the second statement. But if you're curious, I'm putting the bracket here because normally there are 2 statements, and we want to have them in there as an array. So in this case, it'll just be an array of 1 statement. So you put the bracket, then you do a brace for the group statement. So this is the group statement. And then I need to tell it what to aggregate over. And so I'm going to say aggregate in such a way. So the ID that I'm typing here is going to be what ID do I use for my aggregation results. So how am I grouping things? This is not the same as the ID in the documents themselves, although sometimes we will say use those in order to aggregate. But in this case, what I'm going to do is say, because I want distinct shifts and locations, that's what I'll use as my ID. So inside braces again, I'm going to say shift, and I want that to be $shift. So it'll pull all of the distinct values of shift, and then location will be in quotes, $location. $. Okay. So it's going to aggregate all of the unique shift and location combinations now. And then I need to close all of my braces. So let's see, 1, 2, 3. Just for readability, I'll put a space in there. And then close my bracket, close my parenthesis, done. And we get a list back of, so we've got, at Oakland, we've got a shift B. At Oakland, we've got a shift C. At Oakland, we've got a shift A. And we can sort through and see that there are 9 of them. Each location is there 3 times with each of the 3 shifts. And what I'll do is I'll let you guys on your own explore things like how could I sort these, how could I do that. But you know, those sorts of things are available to you. But it's, I think, really the way to learn this stuff, I'll show you these basic examples and then go play with it. Just try different things. And I'll make sure you see how we can look in the documentation for some of the things that we might be interested in. It's all well and good if you guys can mimic what we show you, but we really need to get you to the point where you can go and research and figure new stuff out too. So I don't want to show you every detail. That said, you can always ask questions. Okay, so that tells me I've got 9 distinct location shift pairings. For larger data sets, you'd probably want to do some sort of counting mechanism on that. Again, it's returning that, so let's see if this works. So I don't actually know if this is going to work because it didn't return it directly as an array, or at least from the notation I don't see brackets. So, but we just try stuff. And so in this case it does not. So anyway, play with things, figure stuff out. MongoDB is relatively new to me as well. I've learned how to interact with it just enough to get the data that I need. So what we're trying to cultivate is an attitude of experimental, just try stuff, curiosity and experimentalism. Okay, so the next question up is what's the total number of March events? And I'm going to do this 2 ways. Oh, excuse me, I'm only going to do this one way. I'll do the next one a couple of ways. So again, db dot, let me clear the screen. db dot lab data dot aggregate. And we know that all of the events are in March because we looked at the dates, so I'm not going to worry about that. But you might need to, at some point, use a match statement to match the dates correctly. So we'll see examples of the match statement here in the next question. Okay, so here, what I'm going to do is show you how to do a sum. So group and in this case, what I'm going to do is use for my ID, I'm actually going to use the ID column in the documents. And then I'm going to create a result called total. You can call it whatever you want, but I'm going to call it total. And that result is going to be a sum. So what I'm going to do is $sum. That's one of the built-in operators. I'll talk more about those in just a minute. And what I want to do is sum across the event counts. So I'll do $event. So the $event it'll then pass in the actual numbers so that it aggregates across those numbers. 1, 2, 3. Oops, I only need 2 more. Bracket, parentheses. And so we get a new document out as a result, and it says the total number of events here is 178,328. So that's what we should get if we add up all of the events across all of the documents. And again, you've got the raw data, so you could go and pull that into R and verify that, or in Excel, or whatever you want to use to verify that. In fact, your project is going to ask you to use a data set in 3 different environments and then comment on the merits of each of the environments. Okay, so let's take a look at what we need to do if we want to aggregate, but we want to do it in a certain way. So the next question, number 8, says, what's the total number of events by shift? So this I'm going to show you 2 different things that you could do. The first thing I'll show you is how do I do it for just one particular shift, and that'll let me show you the match statement. So what we'll do is say db.labdata.aggregate. And so now my first statement is going to be a match statement, so $match. And let's do the A shift, just A is first. So I'll do a match, and then in braces I do shift. And I want the shift to be A. If you're curious, the white space is for readability, and there are no defined standards for that, so I'm just trying to make it reasonably readable here. Okay, so close the match statement, and so that'll say only use the documents where shift has a value of A. All right. Okay, so comma, because we're going to now put a second statement, and now we use the group statement. And the group statement for this one is identical to the previous one. So group, and then we're going to say ID, use the ID object. Total is going to be in braces, $sum, and then in quotes, $event. All right, and I think, let me just make sure I counted everything correctly there. It looks right. And so A shift has 89,399 of the total events, so about half. All right, so this might be in a context where the A shift, it's the daytime shift, it's the busiest time, right? So they have over, half of the events. Okay, so that would show, and I could do this again, and if I hit the up arrow, it puts the line of code that I used previously. So if I want to now get the B shift, I can just hit the up arrow, go back, change A to B, and run it again, and we'll see the B shift has about 60,000 events, 59,491. And then I could do the same for C. But if I want all 3 of them, now what I'll do instead is I'm going to include that in my grouping. So what I'll do is I'll delete out the match statement, because now again we're going to use all of the documents. So group, and for ID now what I'll use is, see if this works right, the different shifts. It's an unfortunate typo. And let's see if this works. And we get the total for each of the shifts. So if you wanted an individual one, the match statement is the way to go. If you want all 3, then you can just do a group statement that uses as its ID however you want to group things. And then if you wanted to do location and shift, so question 9 says, what's the number of events in March at the West Edge location by shift? All I need to do here is modify my ID element and say I want shift equal to shift. Location, location, and then I need to close the brace for that and put a comma, and then total is going to be sum across event. And whenever you do the up arrow trick and then modify a line, you got to be careful. I want to make sure I've got the same number of opening and closing braces. And I think I've got it right. And so here we get the numbers by each shift and location. And again, if I only wanted one in particular, so I think this says at the West Edge location, what I would do instead is a match statement. And actually, that's too messy to edit, so I'm going to write it from scratch. So DB lab data aggregate. And then the first statement is going to be a match statement. And what I want to match is location, Westnedge. So that's my match statement. You can think of that as very similar to the where part of a SQL query. And then I'm going to do a group statement. And this is going to be very similar to what we did before. So my ID for the groupings here will be shift $shift. So we're going to group them by shift, and we're only taking the ones at the Westnedge location. And that's the ID that I need. And let me just count. Yep, okay. And then I'm going to call it total and do a $sum $event, and that'll add up the numbers for the events. Okay, so 1, 2, 3, I believe. And now at Westnedge location we get the 3 different shifts. So that's an example of a relatively simple aggregation. Okay, so I have one more question here, question number 10. So let's take a look at that. What's the average number of events by location? Excuse me one second while I pull up the right sheet on my notes. Okay, so what we're going to do here is we're just going to make one change to our code. And I've been doing a sum so far, and I can do average instead. And so for average, it's AVG. And the average here is going to be mean. So it calculates a mean. And we can see now what we get for the average at each shift at Westnedge. The question actually asks what's the average by location. So strictly speaking, what we should do here is get rid of the match statement. So I'll do that. And instead, I'll include that in my grouping. So shift and location. I think I've got everything in there. And now we get the average for each shift at each location. Okay, so let's see. So the ID equals ID is just to say we're returning a total, so call the ID of the object ID. When I do ID colon and then shift location like I'm doing here, we can see what happens to the ID of each object. It's one of these shift location combos. So I've just highlighted the ID for the first object returned. So it's returning a set of 9 documents, and each document has an ID. And so in this case I've said use as the ID the combination of shift and location. Up above where I said ID is just ID, let me find one of those. Right here. You can see in the document that gets returned, the ID that's used for that document is just ID. So that's all it is. I'm giving it a name of sorts for the ID for the documents that are returned. Remember, everything that comes back to us here is a document in MongoDB. Okay, so that's the lab, and again, the materials are there for you to try and for you to experiment with. I do want to talk a little bit about what's available to you in terms of documentation and resources. So if you, not right this second obviously, but if you look in your book, on page, let me find it. So the aggregation stuff is on, right around page 155 in your book. So it gives some simple examples there. The book is not terribly complete, though, in terms of aggregation. So what I would suggest, what does that mean, Mike? Tulasi, can you elaborate where you're seeing that?
Yeah, it says $sum equal, well, :1. Yeah, it's some kind of accounting syntax, I guess. So I saw that and I said, I don't know where to use that.
You saw that with something that I did?
No. I was looking at it this morning.
Oh, okay. Yeah, I don't know.
Okay. Already. Yeah, no issues.
It might be that it's doing a count of each document counting once. So it looks at all of the documents, and for each one it adds a 1.
Ah, that makes sense.
Yeah,
yes.
That's my guess.
Yeah, perfect. Thank you.
Because what we're doing is sum events, and so it's putting the number of events in there. So in your case, it looks like it's just putting a 1 in there for each one. So that would do exactly the same thing as the count is doing in that generic function that we looked at the beginning, right? Just how many documents. It's a more complicated way to do the same thing, but that might be useful if you're doing a count, but you have a match statement as well, right? We might not want to count all the documents; we just want to count certain ones. So that would be a way to do count when you want to do a match statement. Okay, good.
Got it. Thanks.
Okay, so other resources then. Again, the aggregation documentation in MongoDB is very good. At least I think it's pretty good. If you start at the beginning, it introduces the basic concepts, the pipeline. It also talks about MapReduce and the basics of that. We're going to do that tomorrow. And then it has what it calls single-purpose aggregation operations. That's like the distinct and the count. And you can click on that and see more about those. But then it walks you through all the different concepts. And the most valuable stuff to me is these examples. So there's this zip code dataset examples. And you can download it. Here's the link to download the actual zip code dataset so that you can run all of the examples on your own and try other stuff. And in fact, the assignment for this week asks you to do that. And so when you're doing this assignment, I think it's the assignment. It might be the quiz. Use these examples as a starting point, right? It compares it to SQL here for you. Here's how to return an average. So you can see that you can actually do a double group statement. And so that's the output of that. Well, play with it. Just take a look at these examples, and then try and modify them to answer different questions. So this is what I would suggest you use as your primary resource on the aggregation materials. It's actually pretty good stuff. JavaScript resources. So first I'll point out a book. So let's see if I can find it quickly. So the book that I recommend to a lot of beginners is Eloquent JavaScript. I haven't found a perfect book. You're almost never going to find a perfect book. And it says it's an introduction to programming, but I think it's a little bit steep for brand new programmers. But of course the good news is none of you are brand new programmers. So this, to me, is a good starting point. However, if you're going to order it, I will just point out that the new version is coming out in about 3 weeks. So you won't need any deeper JavaScript knowledge for this course. So I would encourage you to wait for the newer version. I have the older version on my bookshelf, and it's perfectly fine. But if you can wait 3 weeks, then I would wait 3 weeks. So that's the book I generally recommend for JavaScript. It got me enough knowledge to get through a couple of projects a couple of years ago. Does anybody have favorite tutorials on JavaScript? I'll just ask you guys. I'm not as familiar with web-based resources, so we'll do the standard trick when we're looking for resources is Google it. So if you guys can find stuff that you like, let me know, or start a discussion thread, or something like that. So we're talking about how to fit a little bit more JavaScript into the curriculum. So at some point we'll probably have some resources there for you guys. Right now we've done more JavaScript in this class than they've done in the past. And you can see how little we've done, right? You'll use JavaScript when you get to the visualization course. He uses visualization with d3.js. So you'll get a chance to do a little bit more with JavaScript there. So we're looking at how we might want to build in a little bit more. But for now, if you can use the syntax that we're showing you for MongoDB, you're good. And I'll look into I'll ask Andy Catlin. He's teaching the other section, and he and I are building out the course. I'll ask him if he has any good ideas for JavaScript tutorials as well. He's more the SQL guy, and I'm more the R guy. So he might have a better sense of that. He does a lot more with programming. All right, that's it. I know we scheduled 6:45 to 7:45. I'm happy to answer questions, but I didn't want it to be too long of a tutorial. So if you didn't follow along and do it as I was going, again, the materials are right there in the Blackboard site, and I'll post this video here in just a minute. So I'm going to stop recording. But that doesn't mean we need to.